Okay, so today we are going to start Unit 4. All right. What Unit 4 covers is polynomials. All right. So we are going to learn what a polynomial is. All right. The components or pieces of a polynomial and what makes it a polynomial. And then we're going to see how we can utilize polynomials in math. Okay. So for lesson 1, it covers the properties of integer exponents and scientific notation. Okay. Uh, and remember, exponents is just repeated multiplication. All right. That plays a key factor in today's lesson. These are the standards that correlate to Unit 4, especially lesson 1. And the question we are trying to answer is how can I apply the properties of integer exponents to generate equivalent numerical expressions? Okay, so anytime I have a number with an exponent, so say we have 5 squared, all right, or 5 cubed, or 5 to the 4th power, okay, what can I do with that exponent? Anytime I have another exponent multiplying with it, dividing with it. So say like we have 5 squared times 5 cubed. What can we do with those besides just simply calculating it? All right, we're going to talk about and discuss various rules that we can do to simplify it before we just straight up solve the problem. Okay, so before you, we have a table. Okay, we have the 5 descriptions or 5 situations of exponent rules. Okay, multiplication of like bases, division of like bases, power rule, power of a product, and power of a quotient. Okay, for the property, it's for the property column, it's just going to cover what that rule is. Okay, what that property is. Then we'll do an example, and then we will stretch it out in expanded form so that way you get a bigger idea on what it actually looks like. So for multiplication of like bases, essentially what that's saying is anytime you have two numbers with the same base, all right, what do we do when we have exponents attached to both? So say we have the letter B, okay? Letter B squared times the letter B cubed, okay? What do we do? So what you do is we keep the base, all right? Keep that same base. And then we add the exponents. Okay. So if we are multiplying like bases, which in this case is b, you add the exponents together. So let's look at an example. Okay. Say we have 5 squared times 5 cubed. Okay. What we're going to do is we are going to keep the base. We're keeping our base, which is 5. And we're going to add 2 and 3. Okay. So we got base of 5, we're adding 2 and 3. What that results in is 5 to the 5th power. That is our simplified expression. Remember, we're not solving it, we're just simplifying stuff. What that looks like all stretched out. Okay. Say we have, for 5 squared, we have 2 5s times 5 cubed, which gives us 5 5s. That gives us a grand total of 5 5s. All right. And since we are multiplying all of them, it's 5 to the 5th power. Because remember, exponents, it's just repeated multiplication. So instead of writing out 5 times 5 times 5 times 5 times 5, we can just write 5 to the 5th power. Now, what happens when we have division, okay? When we have a division issue, what we do is we'll use the example from earlier. Say we have b to the 5th and b to the 3rd. With multiplication, we had to add the exponents. Division, since division is opposite of multiplication, we're going to do the opposite of addition, which is subtraction. So we'll do b 5 minus 3. Okay. Now let's do this. Let's do an example. All right. So we're going to do an example. We're going to use the example from earlier. Okay. So say we have 5 to the 5th over 5 to the 3rd. Okay. We're going to keep the base, which in this case is 5. And we're going to do, since it's division, we are going to subtract the exponents, which in this case is 5 minus 3, which results in the answer being 5 squared. Here's what it looks like all stretched out. Okay. So 5 to the 5th power means we have 5 5s. 5 to the 3rd power means we have 3 5s. What ends up happening is the 5s on the bottom end up canceling some out on the top. So we have 3 5s. So we're going to scratch those out. Because we scratched out 3, or we subtracted 3 from the bottom, we got to subtract 3 from the top. What ends up happening is we end up with a remainder of 2 5s. Okay? So the reason 5 squared. Now, here's what happens when you are dealing with a power. All right? We've been dealing with multiplication and division. Now, here's what happens when you are dealing with it being a power. Okay? So, say we have 5. Nope, don't do 5 yet. Say we have b to the 3rd. All right. And b to the 3rd, and we're raising that 2 more times. Okay. What we end up having to do is with multiplication of like bases, we had to add. Division of like bases, we had to subtract. With a power rule, you end up multiplying those exponents. Okay. So once again, let's take a look at an example. So say, once again, we'll use the same example from earlier. So say we have a base of 5 squared, and we're cubing that. Okay. So 5 squared raised to the 3rd power. We are going to multiply the exponents. And since we are multiplying the exponents, that is 5 to the 6th. The reason being, okay, the reason this all works out is if you remember, exponents, all right, is repeated multiplication. Exponents is repeated multiplication. All right. So essentially, we have three sets of 5 squared, or three sets of 5 times 5. Okay, three sets. Okay, three sets. And with expanded form, we're just seeing what our total number is. So we have a grand total of 1, 2, 3, 4, 5, 6 fives, or 5 to the 6th power. Now here's where things get a little possibly crazy. All right, power of a product, power of a quotient. Okay, so power of a product. Say we've got an example here. Okay, I'm going to add the letter A this time because it'll say we have two numbers that are multiplying one another. So A times B, and we are raising it to a certain power, like squared. What we end up having to do is square each number. Okay, we are squaring each individual number. So say we have 5 times 3 in parentheses, and we're squaring whatever that is. 5 times 3, and we're squaring it. Okay? What we're going to end up doing is just squaring each individual number. So 5 squared times, nope, 3 squared, not 5. There it goes. Okay. Which results in this being some really big number. Ends up being like 25 times 9, whatever that is. Okay. What this looks like all stretched out. All right. Here's why. Here's why this is. If you recall from power rule, all right, we had 5 squared to the 3rd power. We had 3 sets of 5 squared, or 3 sets of 5 times 5. This is a similar situation. Okay. We have 2 sets of 5 times 3. The first set, and then the second set. Okay. We have 2 5s, 2 3s. That's why it is 5 squared. Why did I keep writing 5? And 3 squared. Okay. That's why it's like that. Now, last but not least, okay, power of a quotient. Meaning we're going to deal with a division problem now. Okay. Power of a quotient, we're going to be dealing with a division problem. Okay. So say we are dividing A and B. What do we have to do if we end up cubing it? Just like with power of product, where we had to square each individual number, we're going to cube each individual number in the division problem. That's all it essentially is. That's all we are doing. Okay. So say we have 6 divided by 3. And we're raising that to the 4th power. Okay. Remember, we're not solving this. We're just getting a better picture of it. Okay. So 6 So we're going to attach the exponent to each individual number within the division problem. So this ends up being 6 to the 4th over 6 to the third, 3 to the 4th. Okay. The reason being, all right, just like with power product and power rule, where we had sets of numbers, we have 4 sets of 6 over 3. Okay. Which leaves us, all right, and because we have 4 sets of 6 over 3, that gives us 1, 2, 3, 4 sixes and 4 threes. Okay. So using what we just learned, we're going to look at each property or each description more individually now, and then work on some examples. Okay, so we can get more practice.